Hello, so my students have asked me to do a question from their textbook, and we're going to look at this question here. It's called question 2. What I'm going to do is I'm going to read it. I'm not going to write up on the board, but I'm going to read the question and we'll go through the working. So the question here has that we have an object that's moving in a straight line with position by s of t is equal to t cubed minus 11 squared or 11t squared plus 24 t, and t is greater than or equal to 0 and t is in seconds. Okay? It's asking us to describe the initial conditions of the object. So in order to describe the initial conditions of objects, I'm going to have to find what the velocity function is and what the acceleration function is. So the velocity function is the first derivative of this. So we've got 3t squared minus 22t plus 24. And a of t is equal to 6t minus 22. So I found out what my velocity and acceleration functions are going to be. I now need to find the initial conditions. So to find the initial conditions for s of 0, I'm going to get 0. Because if I plug t for 0 in there, it's at the origin. For v of 0, if I plug t near to 0, I'm just left with 24 centimeters as a positive. And if I have a of 0, I'm left with negative 22 centimeters here. So let's rewrite this underneath each other. I have s of 0, which is equal to 0, v of 0, which is equal to 24 centimeters per second, and a of 0 is equal to negative 22 centimeters per second. So it's asking me to describe this. So if I was going to describe this, I would say that the particle is initially at the origin, moving at 24 centimeters per second to the right, and decreasing in speed. So that's the first part of this question, part A, describing the initial conditions. So I have to find the functions, equate each of those by replacing t with 0, and then explaining what's happening at that exact point. At that exact point, it's at the origin, it's moving to the right by 24 centimeters per second, and it's decreasing in speed because these two signs are different. So let's have a look at B now. It's now asking us to find the velocity function. Well, I've already done that. That velocity function is just here. So here is what B is. So I don't actually have to do any work on it. So I've done B. C is now draw the sign diagram for S of t and for V of t. Alright, so let's do the sign diagram for each of these. Alright. So I'm really going to write up over here, because I'm probably know I'm going to need it later on. When I had t is equal to 0, S was equal to 0, V was equal to 24 centimeters, and A was equal to negative 22. Alright, so let's break this up. We've got S of t here, we want to find the sign diagram, so we need to equate this to 0. So I get t cubed minus 11t squared plus 24t is equal to 0. I can put this into my calculator and work it out, but it's no fun. What's the one thing I can do straight away is I can factorize. And what's common in each of these? It's t. So let's bring the t out. And now I've got something in the middle that I can actually factorize. Let's check if I can factorize with the null factor law. Two numbers that I can multiply to give me 24 and add to give me, yep, I can do that. So therefore, I can say that I've got t, two numbers that multiply to give me 20, add 24, multiply to give me 24 and add to negative 11. And those values will be, let's say, negative 8 and negative 3. Negative 8 times negative 3 is 24. Negative 8 minus 3 equals negative 11. So therefore, t is equal to 0, or t is equal to 3, or t is equal to 8. So let's do the sign diagram for that function. Alright. So here is the sign diagram for s of t. We've got 0, we've got 3, and we've got 8. So if we plug in a value between 0 and 3 into this function, and I've already done that for you already, I'll give you the answers here. You should get positive, negative, and positive again. So there is our sign diagram for the position vector, or position function. For your velocity function, and let's put this here, we will get, and I'll raise this and put this over here a little bit further. I should have put it. Okay. So we get 3t squared minus 22t plus 24. All right. We want to equate this to 0. So 3t squared minus 22t plus 24 equals 0. We got the cross multiplication thing that we do. Not you. Cross multiplication. So how does that work again? We want to work out two factors that make up this. Well, that's going to be 3t and t. And two numbers that multiply to give me this, but when I cross product them with these two, it should give me negative 22. So we think of all the factors. We've got 1, we've got 2, we've got 3, we've got 4, we've got 6, we've got 8, we've got 12, we've got 24. Only two of them are going to work. 1 and 24, gone. It's not going to be. There's no way I can add those two to get this. 2 and 12, gone. There's no way I can add those two with these to give me that. 3 and 8, so we could try 3 and 8. Let's do 3 and 8 here. 8 times 3 is 24. Even if I add or minus to that, I'm not going to get 22, so it's out. So let's try 6 and 4. Now, one thing we also need to notice when it comes to this is these two values have to have a positive or negative onto it that makes sense of this. So when I add these together, they become negative, but when I multiply them, they give positive. So therefore, I'm going to make them negative. And now we're going to work them out. Negative 4 times 12, negative 4 times 3 is negative 12, minus 6 is negative 18. Well, that doesn't give me that. So let's try it around the other way. So we're going to cross multiply. Negative 6 times 3 is negative 18, minus 4 gives me negative 22. So therefore, I can say that negative 3 times negative 6 is equal to negative 18t, and t times negative 4 is negative 4t. So that gives me negative 22t, which makes sense. And I already know this equals 24. So now it's just a matter of writing the factors as a cross from each other. So the factor pairs for this here would be 3t minus 4 is equal to 0. So therefore t equals 4/3. Or t minus 6 is equal to 0. So t is equal to 6. Notice they're both greater than 0. So therefore, let's do the sign diagram for the v of t. Remember, it's a v of t. We've got 4 and 6, so 4 and 4/3 of a second, and 6 seconds. Again, I know that we're going to get something that kind of looks like this is our answer. So we've now got our sign diagram for our velocity function, which was part C. Now part D is asking us, well, at what times is the object at its origin? Well, I've already got the information. The information's up here already from part C. okay, where we drew the diagram, we knew that it is at 3, 8, and 0. So for part D, the particle is at the origin at time t equals 0, when t is equal to 3, and when t equals 8 again. So at 0 seconds, 3 seconds, and then 8 seconds, it's back at that origin. And that's part D. Part E is saying at what times does the object reverse direction? Find the position of this object at each of these times. Okay, well, we've already got that information as well. We know that when v of t is equal to 0, that's when it has a change of direction. So we have a change of direction when t is equal to 4/3 and when t is equal to 6. However, this question is asking us find that and then find out the position. So therefore, I now need to, and I'll rub all this part out here because I know I'm going to need the other stuff. I'm now going to plug in 4/3 to get that answer and 6 to get this answer. Now if I plug 4/3 into this equation here, I should get 14.8 meters. And if I plug 6 in, I should get negative 36 meters. So after 4/3 seconds, I'm 14.8 meters away from the origin to the right, and after 6 seconds, I'm to the left of the origin by 36 meters. All right, let's look at the last part. This last question here, and it's asking us to draw a motion diagram for the object. So if we draw the motion diagram, let's do it up here. I have a feeling I need all this other information to be able to do this motion diagram. So if I draw this motion diagram, all right, where am I originally starting from? So where am I originally starting from? I'm starting from the origin, because at t equals 0, I have this origin. I know that after 3 seconds, 4/3 seconds, so I'm going to put 4/3 of a second here. After 6 seconds, actually, I won't write that here. That's 14.8 meters, all right? Yep. Here I've got 36 meters, because this here's the position. All right, and that's about it, I think. What about changing directions? I'm changing direction in those points. So I'm starting here. I am traveling to the right. Okay, because I know that this here is telling me, for that first part, I'm going to the right. It's at this point here, when t is equal to 4/3, that I start changing direction. Okay, how do I know that? Because I know that initially I'm going that way. And it's not until I meet 4/3 seconds is where I change direction after 14.8 meters of travel. So that means now I'm going from positive to negative. And I change direction again at t equals 6, or when I'm at 36 meters. So I'll come back up here, and I can say that at t equals 6, that's when I've changed direction again. So this here is saying we can now draw and explain what's happening. Initially, the particle is at origin, traveling at 24 meters per second and decreasing in speed. It then changes direction after 4/3 of a second and travels to the left for 6 seconds, and then changes direction again and travels to the right for forever until we find another turning point. This here is that graph of what this equation is looking like. Now, if we were going to sketch this in normal sense, I could sketch this and get the graphics calculator, and I'd get something that looks quite similar to this. Anything that is above the y-axis is positive, anything below is negative, so it's going backwards. But this question here is a little bit different to the other example I did, in terms of I had to find out the sign diagram for the stationary, for the position. Alright, I hope that made sense, and I'll see you in class.